Hello class, welcome to this other special video on the rule of inverses. The reason for a second video is to make sure that one video isn't very long and to really emphasize this rule of inverses because this is something that is commonly missed in the past. Okay, so if you have two functions and you can determine if they are inverses, the real trick here is we are trying to verify that the functions are inverses. Okay, verify is going to be the key word. Not that we're not trying to find the inverse. We're trying to verify that two functions are inverses. And the way you do that is you need to do two things. Okay, so if we have f of x and g of x, if they are inverses, then we must find f of g of x, and it has to be equal to x, and meaning also have to do this, we need to find g of f of x, and it also has to equal x. So if you see the word verify, that means you need to complete two compositions of functions, and each composition must equal x for you to say and verify that they're inverses. Real simple example right here is f of x equal to x minus 2 and g of x equal to x plus 2. Are they inverses? Again, so what I have to do is, if this is f and this is g, I need to do f of g of x, and I got to find out that that has to equal x, and I need to do g of f of x to solve that and make that equal x. So first off here, g of x is x plus 2, and so I have f of that, and then f tells me to take whatever I have an x and subtract 2. So for f, it's x minus 2, and in this case I have x plus 2 in there, and when I solve that I would in fact get x. That is only halfway done. I've halfway verified it. There are functions out there where f of g will be x, but g of f will not. So in this case now I'm going to take g of f of x, and that is x minus 2, and looking at what g says, g tells me to take x plus 2, and in this case, instead of x, I have the function x minus 2, and x minus 2 plus 2 does in fact equal x. I have it, so then I can say yes, they are inverses. I have verified when they are inverse. Let's look at two more examples. Here's one. Now I used a little different notation here, but not to worry. Here's f of x, and this is now f inverse of x. All right, so we're making an assumption, but we don't want to assume. So look over here. Notice I got to do the composition of f inverse and f inverse of f. So we have to do the two compositions. So I have to do f of f inverse of x, and I got to find that. And I need to do f inverse of f of x. Okay, I have to do both compositions of functions. All right, so f inverse is x plus 2 over 4, and I have f of that. Okay, so f function tells me to take 4, multiply it by the x, and subtract 2. In this case, I have inside of the function x plus 2 over 4. And if I think about that, I got to multiply fractions, so that is going to be 4 over 1. And then I could reduce those 4's right there, and that's going to leave me with x plus 2 and then minus 2. And lo and behold, that does in fact equal x. But again, that's only half of the verification. I forgot to mention, notice that word verify. Okay, the word verify will only show up when I want you to do this in the compositions. It's not find the inverses, it's verify functions are inverses. All right. Now we're going to do the other composition, the inverse of the function. So I have f, and f is going to be 4x minus 2. The f inverse of that and the inverse tells me to take x and then add 2 and then divide by 4, and I'm taking that of x minus 2, or 4x minus 2. So I would first simplify the numerator. All right, in the top there, I could do 4x minus 2 plus 2, all right, and that will in fact be equal to 4x, and then I have that divided by 4. That does in fact equal x. So I have checked that off, I've checked that off. You can write at this point, yes, they are inverses. You can say they verified the inverses. You could write the check marks. In fact, you could even just leave it without the check marks as is, and that is proving the verification. All right, we're gonna do one more, and again, I want you to see the note. The word is verify. Whenever you see the word verify, there is a different concept that you must complete than just simply find the inverse. And again, I gotta find the both compositions of functions. And if I find both compositions, then they both simplify to x, then I have proven that they are in fact inverses. So I did g in this case. I have g and g inverse. All right, so again, I have to find the g of the inverse, which is g inverse of x, and we'll find out what that equals. And again, I have to figure out the other composition of g inverse of x, or g inverse of g of x. All right, I'm gonna give myself a little more room, move that down. So let's practice here, and now in this case, g of x is the cube root of x plus 5, and g of that, g tells me to cube and then subtract 5, and I'm going to take the cube root of x plus 5 there, and that is going to be x plus 5, then minus 5, and that is in fact equal to x. Again, there are functions out there where the first composition does equal x and the second one does not, so you do have to complete the second process here. I have to find then g inverse of g, and g is x to the third minus 5. Okay, and now g inverse tells me I need to take the cube root of something and add 5 first, actually. And I'm going to take x to the third minus 5. And again, I have to add 5 first. So inside there, x cubed minus 5 plus 5. That will get me x to the third. And then I need to take the cube root of that, and it does in fact equal x. If you don't follow this verification process on a test, quiz, or homework assignment, you will not receive full credit for that problem. You will in fact receive 0 credit for that problem if you don't in fact use the verification steps. Please follow these steps, and good luck.